Hello, Algebra 2 ladies and gentlemen. Today we're going to be talking about the elimination method or the linear combination method. We've been working on solving systems, and the first way that we learned on how to solve a system was by graphing two lines and finding where they intersect. And then the second way that we learned was the substitution method. And now the third way that we're going to learn is the elimination method. So make sure that you have your notes and a pen or pencil. So we need to first define three words in order to understand the elimination method. This is the top part of your foldable under the elimination method tab in that blue foldable. So linear just means lines, and combination means putting things together, and elimination means to take out. So with those three words and what they mean and how we understand them, what we're basically going to do today is we're going to add two equations together in order to try to get one of the variables x or y to eliminate or be taken out. And so we're going to look at four examples in this video, and we're going to try to eliminate a variable by adding the two equations together. So example number one, we need to solve the system. We have the equations 5x plus y is equal to 6 and negative 5x plus 3y is equal to negative 22. So remember, our end goal is to add things together to get things to eliminate, right? One of the variables to eliminate. So if we added each column together right now, so if we added 5 plus negative 5x and y plus 3y and 6 plus a negative 22, we have to ask ourselves, is there going to be a variable that's going to eliminate right away? And our answer for this problem is yes. 5x plus a negative 5x is going to cancel. So we eliminated the variable x. So now all we have to do is finish the rest of the addition problem. So we have 1y plus 3y is equal to 4y, which is equal to the right side of my equation, 6 plus a negative 22, which is a negative 16. And then we just keep solving for y. So divide by 4, y is equal to a negative 4, okay? Now we're going to use y is equal to a negative 4 to plug back into either my top equation or my second equation to solve for x. I'm going to plug it into the first equation. So if we have 5x plus y is equal to 6, I'm going to plug in for y, my answer that I found, which is negative 4, and then bring down the rest of my equation. 5x plus a negative 4 is equal to 6. Well, we need to solve for x now, so we have to do the opposite of whatever's being done to x. So my first step would be adding 4 to both sides. It's going to get rid of this 4. 5x is equal to 6 plus 4, which is 10. Divide both sides by 5, and x is 2. Remember that for systems, we've been writing our answers as an ordered pair. And so ordered pairs are always x comma y. So my answer is 2 comma negative 4. So that's my answer for example number 1. Number 2, we have the equation 3x minus 4y is equal to negative 5 and negative x plus 3y is equal to negative 5. So ask ourselves, if we were to add the two equations together right now as they are, does anything get eliminated? No, it doesn't. 3x plus a negative x would give me 2x, negative 4y plus 3y would give me a negative 1y. So we have to do something to one of the equations in order to get a variable to be able to be canceled. What I mean by that is I have to multiply either the top equation or the bottom equation by a number. So let's say we want to get rid of the variable x. So I need to figure out what number right here would I want this negative x to be in order for 3x plus this second one to equal 0. So if I want this to add to 0, I would need to multiply this entire equation by 3. So let's do that. We're going to multiply this entire equation by 3. So we have to distribute. So 3 times a negative x is negative 3x. 3 times 3y is a plus 9y. And then 3 times a negative 5 is a negative 15. So notice how I distributed that 3 to everything on both sides of my equation. That's very, very important. We need to distribute to every single term on both sides, the left side and the right side. So we just replace this second equation with negative 3y plus 9y is equal to negative 15. We want to add that to our first equation, so I'm just going to bring him down. 3x minus 4y is equal to negative 5. So I just brought him down so I can add my two equations. 3x plus negative 3x plus x cancels. 9 minus 4y, or 9 plus negative 4y, is 5y. And a negative 15 plus a negative 5 is going to get me negative 20. Solve for y. Divide by 5. Divide by 5. Y is equal to negative 4. Are we done? No, we're not done. We still need to solve for x. So I'm going to plug negative 4 back into, let's try our second equation that we started with. So negative x plus 3y is equal to negative 5. So you can plug negative 4 into the first equation or the second equation. Doesn't matter. You should get the same answer for x, but I chose to put it into the second equation. So I'm replacing this y with a negative 4. So I have negative x plus 3 times negative 4 is equal to negative 5. 3 times negative 4 is negative 12. Bring down the rest of my equation. If I have a negative x minus 12 equal to negative 5, I'm going to add 12 to both sides. That cancels, leaving me with negative x on the left-hand side. Negative 5 plus 12 then is 7. Remember that when we have a negative x or a negative variable, that really means that we have a negative 1x. So let's divide both sides by a negative 1, and x is equal to negative 7. But we want to write our answer as an ordered pair, so negative 7, negative 4 would be my answer. Okay, example number 3. So if we were to solve the system, remember we need to ask ourselves using the elimination method, if we added everything together right now as it is, would something cancel? If we added 2x plus 3x, we would get 5x. If we added negative 7y plus 2y, we would get a negative 5y, which the x wouldn't cancel out and the y wouldn't cancel out. So that means that we're going to have to multiply our equation by something in order for one of our variables to be eliminated, right? On the last problem, on example number 2, we only had to multiply the second equation by a number because that just worked out. But this time we're going to have to multiply both equations by something because for x we have a 2 in front of it and a 3 in front of it. And for y we have a 7 and a 2 in front of it. So I'm going to try to eliminate the variable x. So I'm going to have to multiply my top equation and my bottom equation by a least common multiple of both 3 and 2. Well, 3 times 2 is 6, so that's the multiple I'm going to try. So if my end goal is to get the x variable to add and subtract to 0 with the number 6, that's what I'm trying to do. So we're going to multiply the top equation by negative 3, the bottom equation by 2, and remember that when we do this, we have to distribute to everything. So negative 3 times 2x is a negative 6x. A negative 3 times a negative 7y is a positive 21y. And then we have negative 3 equal to times a negative 10, which is a positive 30. Now we also have the bottom equation that we have to do. So 2 times 3x is 6x. 2 times 2y is a plus 4y. And 2 times 10 is equal to 20. So now we're adding these two equations together. Negative 6 plus 6 cancels. 21 plus 4 is a 25y, equal to 30 plus 20 is 50. Divide both sides by 25 to get y by itself, and y is equal to 2. So we can plug 2 back into either our top equation or our bottom equation. I'm going to do the bottom equation. 3x plus 2y is equal to 10. And I'm plugging 2 in for y. So 2 times 2, bring down 3x plus 2 times 2 equal to 10. 2 times 2 is 4. We have 3x plus 4 is equal to 10. Subtract 4 from both sides. We get 3x is equal to 6. Divide both sides by 3. And x is equal to 2. And remember that we want to write our answer as an ordered pair. So our ordered pair would be 2 comma 2, and that is my solution to the system. And our last example for today, example number 4, we need to solve this system. So if we added everything together right now, x wouldn't go away and y wouldn't go away, which means we have to multiply something. So I'm actually going to multiply the top by a -4 in order to get rid of these y's, because 5 times 4 is 20, and we need opposite signs for them to eliminate. So I'm going to multiply this by a -4 in order to get those y's away, okay? So remember, when we multiply, we're going to distribute to everything, all three terms. So -4 times 2x is a -8x. -4 times a -5y is a positive 20y. And then -4 times 7 is going to be equal to a -28. Now we need to add these two equations together. So 8x plus a -8x, that's actually going to cancel my x's and my y's. So now I have 0 on the left-hand side equal to 2 plus a -28, which is a -26. Uh-oh, 0 is not equal to a -26, but I know that I didn't do anything wrong. So what that means is if you get an untrue or a false statement, our solution is actually a no solution. So instead of getting an ordered pair for an answer, when you get a statement that says something is not equal to another thing, like 0 is not equal to -6, that's false, so then that means no solution. So what that means about these two equations is that their lines are parallel and never intersect and are actually causing no solution. So if we were to graph both of these lines in the blue, we would actually have two parallel lines, and that's why we have no solution. I want to thank you for taking such good notes today, and I shall see you soon.